Nice. Okay, so last week we started introducing straight line and looking at how we understand a straight line. Okay, so we looked at different aspects of it. Started by looking at something called the gradient. Okay, so we've heard of the term gradient before. Okay, you will have used the term gradient when talking about hills. Okay, so when you're driving, you might see a wee sign, okay, that says a gradient, or you might have seen it if you're on cycling, things like that. Okay, gradient, how it's effectively how steep it is. That's all that meaning is, okay, when we're talking about straight lines. So how steep is that straight line? Okay, so okay, so someone coming up. Someone's just joining, so I'll give them 2 seconds. Evening, Sandra. Okay, so straight line, 3 main things that we sort of looked at and we started thinking last week. Thanks, Sandra.
Sorry.
No problem at all. Okay, three main things that we started looking about. So one was the gradient, so how steep that line is. Okay, and we wanted to think about 2 things with the gradient, whether it's positive and negative. Okay, so I drew those lines out. So the more you practice that, you'll pick that up pretty quickly. Okay, so positive, negative, and it's just to do with the direction. That will really just give you the confidence that your answer is correct or not correct. Okay, and if it doesn't match what you're seeing in the exam paper or the image that you've drawn, okay, then just have a wee think about that and just double check either what's on your piece of paper is correct or what you've written down is correct. Okay, so that's the first thing, think about the sort of direction when we're thinking about gradient. Okay, second thing we spoke about last week was where it crosses the x-axis. So if you remember, I spent a lot of time drawing these out. Okay, in fact, what am I doing? Get rid of that. Where was it? Where was it? Where was it? I did have a template. How did I forget this? My God. There we go. And there was a wee template, a wee silly template, so we wouldn't use. There we go. XY axis. Okay. So we looked a lot at the XY axis. Okay. So we were thinking last week, where does it cross the X axis? Okay, and I was saying that the rules and the things we were looking at when we were doing factorization, that's where a graph crosses the x-axis. That's us finding the roots of that graph. So when we're thinking about a straight line, okay, when we're thinking about a straight line like that, okay, where it crosses the x-axis would be that point there. Okay, right where it crosses the x-axis. That looks like where x equals, that was a 1, 2 scale, so 1, 2. Okay, when x equals 2, but y would equal 0. Okay, that's an important thing. It crosses the x-axis when y equals 0. Okay, so gradient, where it crosses the x-axis, which we call the roots of the equation, okay, and where it crosses the y-axis is very important as well. Okay, so where we cross the y-axis, okay, becomes very important as well. Okay, and that's when x equals 0. Okay, now that will start to make more sense when we start substituting figures in. Okay, so that scale continued. 1, 2, 3, 4. Okay, so that crosses the y-axis when y equals -3. Okay, and x equals 0. Okay, so they were the three sort of points to pick up on. Then we started talking about the equation of a straight line. And the equation of a straight line is in the format y equals mx plus c. Okay, where y just a position on the y-axis, okay, a y coordinate. Okay, x, similarly, that's just where the position of the coordinate sits on the x-axis, okay, to the left or the right. So x is the horizontal, y is the vertical, okay. And then m is the gradient. Okay, so we put that in as a gradient. And c, that's your y-intercept. Okay, so we'll build on that today and we'll look at how we find that looking at graphs. We'll find out how we look at for given different points. Okay, and we'll just sort of build on that. Okay, so we'll finish off the straight line and then we'll sort of call it a night there. So I'll end the night with showing you an exam paper and an exam question straight from the exam paper. Okay, and we'll see how complicated it can be pushed. Okay, but lots of examples, lots of opportunity to have a wee look in your booklet as well. Okay, nice one. So let's have a wee think about, just want a blank page. Okay, some examples. Okay, so if you got given y equals 4x minus 6, picking out different parts of that. Okay, your gradient in this case 4, your y-intercept okay would equal -6. That would give you the coordinate of where it cuts the y-axis of 0, -6. So it might ask for it in that format. Okay, so if it asks for the y-intercept, put it in the coordinate format. Okay, so remember the coordinates are always in x, y. Okay, so I'll show you an example where the x is put in as another variable. Okay, so graphs are used for different things. Okay, so when a different letter is used, the same format. Okay, the horizontal will come first, vertical will come second. Okay, so always try and leave it, the y-intercept in that format there. Okay, some other ones we looked at last week. Okay, if you had the format of y equals -2x plus 4, okay, the gradient in that case would be -2. Okay, so it would be a downwards sort of facing slope going across your paper. Okay, and your y-intercept, okay, where it crosses the y-axis. Okay, if you were to write it out in coordinate form, it would be 0, 4. So when x is equal to 0, y is equal to 4. You might see some things like that. Okay, so when you get y equals something x, and there's no c after it. Okay, so what does that mean? That means it's cutting the y-axis when when y equals 0. Okay, so the y-intercept is at 0. So x is equal to 0 and y is equal to 0 at the same time. Okay, so the gradient -5 and the y-intercept in that case would be equal to 0, 0. Okay, so a couple of different formats just to look out with. Okay, just to be aware of. Okay. Now, going to look at some different ways that you could end up with this formula and how to rearrange it. Okay, and that's a big part of what we're pushing to do. Okay, rearranging equations. So we'll take that step by step and have a wee look at it. So we'll work on this skill and then we'll look at it later on tonight, how we sort of come about these sort of setups. Okay, so if we ended up with something along the lines of y minus 2 equals 4x plus 3. Okay, if the question is asking for the equation of a straight line, you need to leave it in y equals mx plus c form. Okay, so you want to start collecting the like terms. So you want to move that -2 over to that other side and then tidy up that formula. So you want to leave y in its own. Okay, so we just use BODMAS in this case. Okay, so when we're rearranging, okay, so it's BODMAS when you're calculating, when you're rearranging, you're going the other way. Okay, so you start at the add and subtract and you move that to the other side. Okay, so we've covered that the last few weeks. Okay, so we'd move that -2 over, change side, change sign. Okay, it'd leave us with 4x plus 3 minus 2, y equals 4x plus 1. That would give you gradient of 4, so a positive gradient. Okay, so they might ask something along those lines, it's gradient positive. And we'll give the y-intercept of x is equal to 0, y is equal to 1. Okay, so we'll leave it in that form. Okay. That just comes from there. So the y-intercept when x equals 0. Okay, so let's have a wee look at something a wee bit more complicated. We had 2y 4x plus 6. Okay, and we were wanting to leave that in the equation of a straight line. We'd want to take that 2 over to the other side and leave y in its own. So we always want to leave y in its own. Y equals mx plus c. Okay, so if we've got anything in front of it, okay, if we've got anything added to it, divided by it, we want to get that rid, put it over to the other side. So again, we're using BODMAS. There's nothing being added or taken away on the left-hand side for us. Okay, so we're going straight for the multiples. Okay, so there's no add or subtract on the left-hand side, so we don't need to move that. We're looking for dividers and multiplies. Okay, the multiple we want to move across. Change side, change sign. That can be written like that. Okay, or you could split that up. Because if you think your rules of fractions, that's the same thing. Okay, so we can write it either or. Okay, so the right hand side is probably easiest there. Okay, so that just simplifies down to 2x plus 3. Okay, this you can simplify as well. Okay, that top line, we think about our factorization, you can take out a common factor. Then they cancel out. Okay, so that's just wee things that we've been using elsewhere that hopefully should be coming. Okay, oh, that's actually wrong. Sorry, that's 2x plus 3. And that would leave you with 2x plus 3. So it leaves you with the same answer. So you can write it either way. Just be aware that you can do that. Okay, so just our rules of fractions. Okay, so write it either way. Okay, again, that will leave you positive gradient. Okay, y-intercept of x equals 0, y is equal to 3. Okay. Just to make sure we're sort of comfortable with that. Okay. So this time we do need to be careful with what we're doing in regards to reverse BODMAS. Okay, so when we're moving things over, remember we're going that direction. First thing we want to deal with is that add and subtract. Okay, so the first thing we want to deal with is that minus there and move that across. Okay, so first thing we want to deal with on the left-hand side when we're trying to leave the y in its own is that negative 10. Okay, oops. Change side, change sign. And we're left with that. Okay, someone's just coming in. Okay, continuing along, so we've no more add or subtract there. Continue along that BODMAS in a reverse direction. We go to multiply or divide. Okay, deal with them, so we can deal with that 4. Okay, because that's a 4 times y. Okay, so we move that across. Okay, similar to what we just did above. When we move that 4 across, we can either write it like that, or you could write it like that. Okay, both are correct mathematically. Both take roughly the same amount of time. So if you're comfortable with, go for it. Okay, so that'd be 2x. That would be plus 3. And to simplify that over this side would be 4. Can't draw an X tonight. And the 4's cancel out. Okay. Nice one. That really rounds off what we were looking at in regards to that equation of a straight line. So that's where we want to get to. So I'm going to give you a couple of questions just so we're comfortable with that. Okay, and I'd like you to just practice that. We'll go over the answers quickly. Question. No problem, Richard. No problem. No trouble. Okay, and then we'll sort of round that out. Okay, so I'll write these down and then we're just trying to rearrange it, Richard, just so it's in that form. So you're just trying to rearrange so it's in y equals mx plus c form. Okay, so if we do just try these yourself. Okay, so you're trying to find the gradient and the y-intercept. Okay, so I want the coordinate of the y-intercept. Oh, this is going to get quite tight. Whoa. Okay. Have a wee bash at those 8 questions. Okay, so say 2 minutes a question, 16 minutes, so 48. So let's come back together at 10 to 7. Okay. Have a wee bash, so that all right, 2 minutes a question. That, no problem. Okay, so let's get back together at 10 to 7. All right, nice one, guys. Okay, so quickly blitz through the answers. Okay, so okay, so number 1, gradient for y-intercept would be 0, -3. If you have got any of these wrong or it's not what you've got, give me a wee shout out. Okay, I just did them very quickly.
How did you get the north in the first one?
This one?
Yeah.
That intercepts the y when x is equal to 0. Okay, so conveniently. So say we had 4x. Okay, straight line. Where's my straight line button? Okay, straight line, and it was going through -3, which is that one. Okay, so that coordinate for that point. Okay, so we're thinking about a specific point in the graph. Okay, the coordinate for that point would be x is equal to 0 and y is equal to -3. Okay, that's where it's cutting through that y-axis. Okay, so the y-intercept is always when x equals 0. Okay, so x is equal to 0. 1, 2. Okay.
Okay.
So if they're talking about the y-intercept, x will always be 0 in the coordinate. Okay. 3. Did you get the 9 part of it?
Yeah, I did, yeah.
Cool. That's better.
I get so far and then I get confused.
No problem. That's why we're here. Y-intercept, what have I got? 5 -3. Okay, 6 is a wee bit more difficult. Okay, so the answer is m equals 3, y-intercept equals 0 and 4. Is everyone comfortable with that? Okay. 7, m equals 2, y-intercept 0 and 10. Okay, so that one's a wee bit trickier because we've got the 2x on the other side. Okay, so we had this equation. Okay, and we're wanting to leave it in that format. Okay, so in this time we want to move that over to the other side. Okay, to leave the y on its own. So we're always trying to leave that y on its own. Okay, so moving that 2x becomes positive on the other side. and then that 10 stays positive. Okay, so gradient and where it cuts the y-axis. Okay, comfortable? Okay, and this is the same. Oh, I always put a wee dot in. Okay, and that's very much the same. Okay, so we've got 3y plus 2x equals 9. Okay, so we're wanting to rearrange that equation. So we've got y equals mx plus c. Okay, so first we want to move this over, and then we want to get rid of that 3. Okay, that order is just going to be our BODMAS, and we're going to be working right to left. Okay, so the first thing you move when you're rearranging, you add and subtract. So you'd be left with 3y minus 2x plus 9. And I've put that minus 2x. Okay, it might look a wee bit wrong, I suppose, or a wee bit untidy. Okay, but that's the way the format's it. So we want it in the mx plus c. Okay, if you wrote it like that's the exact same. Okay, so 3y equals minus 2x plus 9 is exactly the same as 3y equals 9 minus 2x. Okay, we've just rearranged that 9 and minus 2x. It looks a wee bit neater that way on the right hand side. Okay, and it still tells you the same information, but just make sure that you're aware what the m is going to be and the c is going to be in that. Okay, so you might see it written like that sometimes. Just be aware that's what they've done. Okay, it's just to make it a wee bit neater. Okay, then it's a case of continuing with your BODMAS. Okay, is there a divide or a multiply? Yep, we want to move that 3 across. We could write it like that, or we could write it the other way. Okay. How did I get that answer so wrong? Okay, so your gradient is going to be left in a fraction, okay, which is quite common in the exams, okay, and the y-intercept is going to be 0, 3, okay. Is that okay? Next one. Okay, so we've got that equation of a straight line. Okay, that is your equation of a straight line. There's a couple of different ways they can sort of form that question. So there's one more technique that we need to look at, just in case the information they give you is a wee bit limited. Okay, let's put it that way. Okay, so they can give you either a diagram where you need to pull the coordinates off of yourself. Okay, so they'll give you a graph. You'll need to work out the gradient, or you'll need to work out a couple of different points to then pull that together. Okay, or they could give you enough information to work out the gradient and one other point on that. Okay, so we need a little bit something. Don't really need this format, but we'll go with it. Okay, so we need another formula to work with that just allows us to do that, but we always want to end up in back at the equation of a straight line, which is y equals mx plus c. Okay, so we always want to end up back there. Okay. The formula that we're going to look at, okay, is to be used when the information is limited. Okay, so we'll go through plenty of examples, but this formula, okay, is y minus b equals mx minus a. Okay, where m is a gradient. Okay, so that's not changed. That letter m is the gradient. Okay, and the letters a and b is just the coordinate of any point on your line. Okay, so the A and B in that format, okay, so x, y, okay, so any point on that straight line, if you know the x position and the y position, you can use it in this format, okay, and it will allow us to get to the equation of a straight line. Okay, so we're looking for two bits of information, the gradient and at least one point in that straight line. Okay. So y minus mx, sorry, y minus b equals m bracket x minus a. Okay. Very, very importantly, this equation is not given in the exam. Okay. Very, very importantly, that is not given in the exam paper. Okay. So you need to know this process. Okay. What is the method? What are we trying to do? Okay. So the method of this that we're going to follow. First step is find the gradient. Okay. Find the gradient. Now you'll either be given the gradient in the question, okay, or you'll have 2 points on the straight line that you can use. Okay, if you've got the 2 points in the straight line, we're just doing our y2 minus y1, x2 minus x1, changing y over changing x. Okay, so find the gradient. So you're either given it to plug into your equation, or you need to find it using that 2 different points. Okay. Second thing, okay, substituting in the coordinate AB. Okay. So that's your known position into the formula. Third is leave in form. Okay. When it asks you for the equation of a straight line, that is the format it leaves. Okay. That is the format it's leaving. Okay. Find the gradient, substitute in the known position or known coordinate into the formula, and then leave in the form, so we need to rearrange it in the form y equals mx plus c. Okay, so let's look at an example of that. Okay. We've got a line and it goes through 0.14. Okay, it's a straight line. Okay, a gradient of 2. Okay, so information we're given, the gradient is 2. Okay, and it passes through coordinate or position 1, 4. Okay, so you don't need to draw that out. Okay, what we want to find, okay, what the question will be find the equation of okay, so we'll just give you that statement. So we'll give you the gradient and it'll give you one coordinate. That's all it will give you, and it will give you find the equation of the straight line. Okay, so it will ask you, well, it's asking you to understand what the equation of the straight line, so it's wanting you to find y equals mx plus c. Okay, we get given m anyway. Okay, so essentially we just need to find this c. Okay, and that's what that other equation's for, that other formula. Okay, so let's write out that formula, then go through it. Okay, so we want to find the equation of a straight line. Okay, so y minus b equals mx minus a. Okay, when m equals 2 and position given as 1, 4. Okay. First thing, and you can write this on your exam paper if you want, you could just put a wee A, B under that. Okay, so that A and B, you're aware that that's your known position. So you're going to use that coordinate in your formula. Okay, so you're going to substitute that in. So you're going to substitute the number 1 where it says the letter A. And you're going to substitute the number 4 where it's that B is positioned. Okay, so we've done substitution before, but not maybe written like this, written out like this. Okay, so y minus the letter B, okay, which is 4. Okay, that's going in here. So we're substituting that in. M is the number 2. X minus 1. Okay. And now it's just a case of solving it. So the difficult part of this is putting the right numbers in the right position. Okay. So just working through, tidying it up. If we break that bracket out, 2x minus 2. Okay, we want to leave it in the y equals mx plus c. Okay, so we want to move this -4 across. Okay, so y equals 2x minus 2 plus 4. Y equals 2x plus 2. Okay, so the gradient equals 2, and the y-intercept equals 0. Any questions? Okay, so we've been given 2 bits of information, gradient and position. Okay, only one position. Okay, so 2 bits of information were given in this one. Okay, so find equation straight line when m is equal to -3 in a known position, so it goes through. Okay, -2, -5. Okay, so -2, -1, 2, 1, 2, 3, 4. Okay, so that's -2, negative. Okay, it's a negative gradient, so it's going to sit at an angle like that. Okay, so it's a negative gradient, so I know how it sits. Okay, I know it goes through -2, -5. Okay, we want to find the equation of a straight line. So we want to leave it in the format y equals mx plus c. Okay, so we're going to use y minus b equals mx minus a. Okay, and that's going to be our AB. So give me a wee second just to digest some of that. Okay, so let's start putting that in. So y minus our b, okay, which is -5. So it's -5. Okay, putting that in the brackets the easiest way, and just to keep it nice and tidy. Okay, so it's y minus -5. Okay, the gradient is -3, x minus -2. Okay, first thing we want to do is fix all our double negatives. Okay, so if you negative a negative, you get a positive. So if you see that 2 negatives together, you're going to get positive, and that becomes positive. Okay, if I do a step and you don't see where it comes from, shout out, put your thumb up, put something in the chat. Okay, 2 negatives beside each other is going to become a positive. Okay, going to split up that bracket. Okay, and then we want to leave y on the left-hand side on its own. Tidy it up, collect like terms. Okay. So gradient equals -3, y-intercept equals okay, does that make sense? Okay, so have a read bash at some of these. Okay, so booklet 2. Okay, so in middle, question 7. Let's have a wee look. That's a question. Booklet you're after, it's pack 2. Okay, so remember, find that in middle. Okay, so in middle, so this pack here. Okay, National 5, pack 2, unit relationships. Okay, so you're clicking on that in the booklet. It's question 7. 7. Okay, so ignore C at this moment in time. A, B, D, and E. Okay, so A, B, D, and E. Okay, so you're given the gradient in 1 point. Okay, so you're given the gradient and then 1 coordinate.
What page is that again, please?
So that is page 7. Page 7 of booklet 2, question 7.
Oh, thank you.
Can I just go back to this drawing? So I gave you a bum steer. That line, oops, should be going like that. The gradient's negative. Oh, sorry, I'm not sharing that. Okay, that's what I drew out. Okay, when we were putting that question together. Okay, that's not correct. That line is a negative gradient. So it should be going through that like that. Okay, so that was my mistake. Okay, I did it as a positive gradient. Okay, so that's drawn out a wee bit better. So it goes through -2 and -5. We've got the right answer. Okay, but I realized that gradient's the wrong way. Okay, so if you've drawn that out, just double check that. Okay, just scribble that out. So I apologize for that. Okay. I hope that makes sense. Okay, so if you could do that, I'll leave that on the screen actually. Okay, let's have a wee break. So let's try, so A, if you try A, B, D, and E only. So A, B, D, and E only. I'll leave that on the screen. A, B, E, E. Okay, don't do C and the rest of them. Okay, so say 3 minutes each, 12 minutes, and then let's take a wee 15-minute break. So 12, let's say 20 minutes. Let's come back out together 7:45. Okay, guys, so try those 4 questions, then take a wee 10, 15 just to clear your head. Okay. Okay. Is it not sharing? Is that sharing? Okay. Okay, so let's think about, gives you this question. Okay, so find equation of straight line. Okay, so that will be, I won't write it out each time, but that will always be the question. Okay, find equation of straight line. Joining points 0, 6 and 8 minus 2. Okay, so they might give you an image of a graph and actually plot these 2 points on it, or they could just leave it like that. Okay, they could just, that's as much information as they could give you. Okay, by saying equation of straight line, we want to be left with mx plus c. Okay, we want to be left with that. Okay, so we need to find out the gradient, and we need to work out a method of working out what the y-intercept is going to be. Okay, and that's by using that equation. Okay, so gradient, first off, with 2 points, we can find out the gradient. So we got 2 points in that straight line, that's just 2 coordinates on that straight line. Okay, so we don't know the gradient, okay, but we've got 2 individual points on that. So we can just do the change in y over the change in x. That will allow us to find out the m. Okay, so if we go back up to this, just say that's x1, y1, that's x2, y2. Okay, and then just do our normal process of substituting that in. Okay, so y2 minus 2 minus 6. Okay, x2 is 8, x1 is 0. Okay, that's minus 8 over 8, which gives a gradient of minus 1. Okay, so we found out the gradient. Now we need to complete that off. So we need to find out what the y-intercept is. And we're going to use our equation, y minus b equals mx minus a. Okay. So we know gradient. Okay, but we need to put something in the A and B position. So in the A and B position, we can pick either of the 2 coordinates. All you need to do is pick a coordinate on that line. It could be any single coordinate on that line. So as long as you know the x position and the corresponding y position, you can use that in this equation. Okay, so we can either pick one of them. Okay, easiest one for us would just be picking this one. Okay. Rub that out this time. So for this formula, the A and B. Okay, and that. Just a case of substituting them in. Okay, so where the letter B is, we put that x equals, and the gradient was -1, x, and then minus A is 0. Okay, just write it out, it's not a problem, but that will disappear obviously. Okay, is everyone comfortable with that line where I've pulled all the different numbers from? Okay, so that we only need a single point in that, so let's just tidy that up. Break the bracket. Okay. That -0 multiplied by that just disappears. Okay, so multiply anything by 0, it just disappears. Okay, so that's what we're left with. Want to leave the y alone. Okay, so we want to move that 6 across. In algebra, we don't write that 1 out, so if I put -x, everyone okay with me doing that? Okay, and then we'll just have +6. Okay, so the gradient and the y-intercept okay. Okay, everyone okay there? So that would be your answer, by the way. Okay, that's just me writing out. Okay, but that's your equation of a straight line. Okay, how about if they gave you an image? Give us quite enough room, but I'm going to change the scale a wee bit on this. Okay. Okay, I'm going to go -1, 7. And then I'm going to have 3, -5. Okay. Okay, so we've got a straight line that goes to -1, 7. Okay. So x-axis -1, y-axis 7, and it goes through 3, -5. Okay, everyone comfortable with those plots? Okay. Question would be find the equation of straight line. And that's it. Okay. That's all the information you'd be given. Okay, so looking at that graph straight away, picking up a couple of things. When you pick up that the gradient is negative, that just keeps you right. Okay, so I know that by the direction of that line going down. Okay, we've got 2 points, -1, 7, and 3, -5. And we're looking to be left with y equals mx plus c. Okay, so that's the format that we want to leave it in to find the equation of a straight line. Okay, first thing we want to do is gradient. M equals the change in y. Okay, so x1, y1, x2, y2. Okay, just substituting that in, just making sure you're being consistent. So y2 is -5, y1 is 7. Okay, so remember that's going to be, just be careful with this sign. Okay. Oops. X2 is 3 minus x1. Okay. First thing we want to do is just tidy up the double negatives, so just be very careful. Okay, so -5, -7 is -12. Okay, that'd be 3 plus 1. Okay, so that negative a negative, that becomes a plus. Okay, so the first thing we thought was going to happen, the first assumption we made, the gradient was negative, so that rings true with what we see. Perfect, good start. Okay, so we've now got enough information to put it into that other formula that we have, and then we simplify that down and we tidy it up. Okay, so y minus b we can pick either coordinate. Okay, so we can pick the -1, 7, or we can pick the 3, -5. Okay, either or. Okay, so I'm going to pick the -1, 7. That's going to be A, and that's going to be B. Okay. Gradient was -3. -1. Okay, so again, be careful with that symbol. Okay, break that bracket. Oh, sorry. Tidy that up first. Okay. Okay, let's have another example. Okay, so practice questions like that. I just looked at question 8 there in the booklet. Okay, that will give you some practice questions on that. Find the equations and lines round. So same with that. So 8, 9, and 10 look pretty damn similar. And the equations of the lines. Yeah, 8, 9, and 10 look pretty similar. Yeah, in your own time, try a weave some of them. Okay, so let's continue. So, what they like to do in the exams for some reason is make the gradient a fraction. Okay, again, that's nothing to be worried about. If you get a fraction for your gradient, okay, if you can't simplify it down any further, don't worry about that. Okay, they do like to do that sometimes. Okay, so let's do a couple that you would see a fraction and then just work it. So we've seen a couple when we were working out gradients and stuff before. We've simplified it down to things like 2/3 and 3/4. Okay, so we've seen it being done for gradients. Let's just put it in that, just making sure we can comfortably rearrange it and break it up. Okay, so if we did an example, find the equation in a straight line. You're given a gradient of 2/3. Okay, and it passes through coordinate 5, -12. Okay, it doesn't give you any other information. Five -12. Okay, so be straight in. That. Just put that underneath it so we're aware of it. Okay, y minus -12, 2/3 x minus. Okay. Okay, so that's me just tidying up the double negatives. Okay, next thing I want to do is break that bracket. Okay, so y plus 12 equals 2/3x. Okay, so we're multiplying the first term, and then 2/3 multiplied by -5. Okay, which would just be -10/3. Okay, so multiplying a fraction, nice and easy, just multiplying that top line. Okay, next thing we want to do is we want to leave y on the left hand side, so we want to move this 12 across. Okay. We're going to get -12. Okay, but we want to tidy that up even further. We want to collect like terms. So we want to bring both of these together. Okay, and it's a simple, what we did when we added fractions together. Okay, whole numbers. Can be written like that. Okay, then you've got that fraction. Okay, so you can take that to one side if you want, write it out over here, collecting like terms. Okay, we're just going to do smile kiss. Okay, so we're just taking away a fraction from a fraction. So we do our smile kiss. Okay, if anyone's unsure what that means, go back. Okay, watch the video. Okay, so we've got -10/3 -12/1. Okay, that would give you a top line of -10 -36 all over 3. Okay, that would give you -46/3 Okay, and we can just put that back in. Okay, that doesn't simplify down any further. 3 doesn't go into 46. There's nothing that can tidy that up. Okay, so that's your final answer. Okay, doesn't look great, doesn't look the neatest, but that's your final answer. Okay, so the difficult bit here is just remembering how to tidy up this part. Okay, so that's a difficult bit with that one. Okay, but it's just that smile kiss. Okay, let's try another one. In the same vein. Okay. Let's see, gives you. Okay, I'll actually just draw this out because it's weird coordinates. X and Y. Okay, we're given a point, -1, -3. Okay, and we're given a point, 7, -9. A straight line going through them. Okay, we're given that information. Find the equation of the straight line joining points. Okay, so we've got point, -1, -3. Okay, and point 7, -9. That's all the information we've got. Okay, we've got to a point, so it allows us to find the gradient. So we go through that process, finding the gradient. Okay, so x1, y1. I would advise you do that underneath the coordinates. Okay, just to make sure you're consistent with what's x2 and y2, x1, y1. Okay, so it is, believe it or not, it's easy to mix up when you're trying to work quickly. Okay, so y2 is -9 minus y1, which is -3. Okay, x2 is 7, -1. Okay, so there's a lot of double negatives in there, so let's just tidy that up. Negative. Oh, that's wrong. It's on it. That would be -6 over 8. So that's us got our gradient. Okay, I'm going to substitute that into our equation. If I skip ahead, give me a wee shout. Okay, again, your A and B can be whatever coordinate you want. Okay, usually the easiest way to do it would be the one with the least amount of negatives in it. Okay, but either one's absolutely fine. Okay, I'll do this one just because it's the first one we came to. Okay, so for this equation, x, okay, if you did 7, -9 and put that in, you would get the same answer. Work your way through, you'd get the same answer. Okay, so y minus -3, gradient was -3/4 minus -1. Lots of double negatives hanging about there, so let's tidy that up a wee bit. Okay, so just tidying up those double negatives. Okay, next thing we want to do is break that bracket. So left-hand side stays the same. Multiply the first term. Multiply the second term. Okay, want to leave y on its own. Okay, so we're bringing 3 over. It's -3. Remember, you can write a whole number as just that number divided by 1. Okay, and that means collecting that like term just becomes a fraction minus a fraction. Okay, again, go through the same process. So you can do that out to one side. You do your smile kiss. Okay, so your top line would be -3 minus 12. Your bottom line would be 4. Okay. And substitute that back in. Okay, and that would be your equation of the straight line. Okay. That's still your gradient. Just because it's a fraction doesn't mean it's anything. Okay, different. That's still where it cuts the y. All that's telling you, it's just not cutting it a whole number. Okay. It looks odd. I'll give you that, but that's all that is. Okay. If it was asking for the equation of the straight line, that's your answer. Okay, what we are. So I'll just do 2 more examples, just so you've got them in your armory. Okay, very similar. That's as complex as that really gets. Then I'll look at past paper from 2019, and then we'll call it a night. So hopefully, you know, hopefully half an hour, we'll be done. Okay, so how about we look at -1, 2. So we have coordinate -1, 2, and coordinate 5, 1, 2, 3, 4, 5. 5, -1. Okay. Let's draw a straight line through that as close as possible. Okay. Given that, okay, usual question. find equation of straight line. Okay, you've got two coordinates. Okay. Now, looking at that, it doesn't matter which you use as your x1, y1, which you use as your x2, y2. Okay, so just to show you, I'll put this is x1, y1, x2, y2. You'll still get the same gradient out. Okay, but this is where you need to be consistent. Okay, so y2 in this case is 2 minus y1, which is -1. Okay, x2 is -1, -5. Okay, so that'd be 2 plus 1 minus 1 minus 5. Okay. Now if I'd switch that round, so if my x1, y1 was the top, my x2, y2 was the bottom. Okay. Let's just have a wee look, just make sure that works out, just so we're comfortable with that. Okay, so if I switch them round, oops. Okay, so if I did it the other way, if you Sam, you did it the other way. Okay, y2, still with some equation. x2 choose 5. Okay, so we end up with the same gradient. Okay, so don't be worried and go, oh, I don't know which one I want to make my x1, y1. Okay, you see, so if you get two coordinates, as long as you stay consistent, i.e. your x1, y1, your x2, y2, then it's fine either way. Okay, so don't worry about that. So that's and or. Okay, so we've got our gradient. That was a wee slight detour. Okay, but we've got our gradient of -1/2. Okay, that makes sense with the line that we see. Okay, it's a negative gradient, so no, we're fine with that. Y minus b equals x minus a. We want to pick one of the coordinates, it doesn't matter which one. Okay, what did I pick? -2. Okay, you can pick either. Okay, so you could have picked the one on the right as well. Okay. So I'll have y minus 2 minus 1/2 x minus -1. Okay, so y minus 2 equals -1/2. I'll tidy up the double negative first. That becomes a plus. And then it's just tidying that up. So break that bracket. -1/2 x. Okay, -1/2. So multiply the first term, multiply the second term. Okay, to break that bracket. Okay, then we want to move that 2 across. And that 2 becomes a plus 2. Okay, and we can write it like that, 2 over 1, because it's a whole number. Okay, that makes it a wee bit easier when we do sum. Okay, so that just becomes 1 minus 1 plus 4 over 2. Well done. Minus 1 plus 4 over 2. Okay, so it's 3 over 2. That's a positive. Okay, so that just goes back in. Okay, so that's our final. Okay. Do one more. It's got find a straight equation of straight line, and the gradient equals minus 3 over 5, and it passes through okay, and that's all the information you get given. Okay, straight into your y minus b equals m x minus a. Okay. Take that over to one side. So we're collecting like terms. Okay, so we say collecting like terms. Okay. That becomes negative 12 plus 50 over 5. It becomes that goes back in. It's odd, but Oh. Take that back, that's positive. Sorry. Minus 12 plus 50 would be positive 38. Apologies. Okay, so some of them can end up quite odd looking. Oh, and that's got an X in it. Starting making mistakes. That's when you know what to call it a night. Okay, some of them can look quite odd. Okay. I want to show you how it can look in an exam. Okay, so that link I put into the email
And 5.
the other day for the website that someone gave me. Okay, so this website, the free Nat5 Maths. Okay, I was having a wee scan through. I've still not been able to spend much time on it. Okay, but what they do have is past papers somewhere, past and practice papers. So it's actually got all your past papers, which is quite good, which is very good. Okay, so I was having a wee look in the 2019 exam, see if there was any questions. Okay, so what it's quite good is just to familiarise yourself with. Now, bear in mind, you are anywhere close to all the subjects. So don't look at this and fluster yourself, okay, by any means. We've not done exam prep, exam sort of format or anything, okay. But this is the past paper, okay. So non-calculator, past paper, okay. There's your formula list, okay. So if you ever wanted to see what formulas you're getting, okay, there's all your volumes. Okay, there's all your volumes that we've worked with. Okay. Seen that before? No, there's a question. Okay, so this is a question I wanted you to look at. So this is a graph and it's got a straight line. Okay, and it's asking you to find the equation of the line. Okay, give the equation in its simplest form. So this is what it could look like. Okay, so when we've been working with X and Y, I've been saying a lot of the times, look, that could be, that is just a stand-in letter for a variable. So that's mean things, okay? So if we look at that a wee bit more closely. Okay, the x-axis, in this case, we've used the letter E to represent engine size, okay? Don't worry about that, that is still your x-axis. Okay, so that's going to be your first point when you're looking at coordinates, okay? Y-axis, okay, they've used the letter F. We've just used the letter F, and it's the same thing, it just means it's just a stand-in letter. Okay, that letter F. So that's just your y-axis. Okay, so your second letter in your coordinate is just going to be your y. Okay. It's giving you loads of different points. That's just to throw you. Okay, so they're being a wee bit awkward just because they can. They've just put loads of different points. What they've done is put a line of best fit. So it's like an average sort of line, and it's, yeah, to bring an average to all those numbers. So don't worry too much about all these different dots. What you're concerned about is your two dots that you see that are actually on that line. Okay, so you've got two dots that are on that straight line. Exactly, boof, boof. Okay, you've got a dot which is on the X, is 1.5, so it's in between the 1 and the 2. Okay, so it's a quite annoying scale. Again, they're trying to throw you. So that point, okay, is 1.5. So you can write it as 1.5. And the y-axis is 14. Okay. This point here, along the x-axis, 3.5. Okay, and the y-axis is 8. Okay, and then it would just be the case of working through that process. So with 2 points, you can work out the gradient, and then you could substitute one of those points into that equation that we've been working on tonight, that formula we've been working on tonight, and just work through that. Okay. Now we've not done any examples where we've switched between, okay, decimals and fractions. So I'm going to leave that alone, but I just wanted to show you that format and show you a graph. Okay, so you start to familiarize yourself with how graphs can look. Okay, so we've not done much of that, but I found that quite interesting. We'll come back to that one day and we'll work through that as a process. If you want to have a go at it, by all means. I don't know if the answer's there actually. Oops. Let's see if the answer's there. Yeah, it's actually got a marking scheme as well. So let's see what the marking scheme says. So this is quite a good, if you have a wee look through that, don't scare yourself, but have a wee look through it. It's quite good. This is really good. See that that one that actually walks you through
Angles and
the angles one quite well and shows you where the marks are coming from. There you go. Yeah, okay.
good.
What was I looking at? There, 7. Okay, so 7, 7, 6, 7. Is it question 6? Question 6, sorry.
Question 6.
Okay, so there's your 2 coordinates. That's them working out the gradient. Okay, so a couple of marks there. That's leaving you with your equation. That's leaving you with the equation. Okay, so it actually gives you the answer, which is quite nice. Don't do part B. Okay, we'll look at part B at a later date. Okay, but I just wanted to see that, allow you to see that, to show you how they would word it. Okay, they'll throw in a couple of things that will try and throw you, but all the words are there. Okay, find the equation of the line. Okay, you can see that it's straight and you've got 2 points. Okay, so there you go. Give the equation in its simplest form. Y equals mx plus c.
So is that still a positive line then?
That's negative.
Or negative?
That's negative. Positive would be up.
Right. Okay.
Okay. So if you think about standing at the highest point, no, that doesn't really make sense, that analogy, does it? If you think about moving along the x-axis, what you're doing on the y, you're going down.
Right. Okay.
So yeah, that's a negative. That would be negative. Okay. Okay, what I would want you to do, so don't try past papers. I just wanted to see, have a look at that. In the booklet 2, they've actually got a bunch of similar questions. Okay, they call them exam questions. I'll have a double check in past papers to see which ones they actually apply to. Okay, so have a wee go at them. Okay, so that's page 8, and it's just straight line exam questions, and it should be in that sort of similar vein of what I just showed you. Okay, none of these change away from y and x, but they're all at that same level. Okay, in fact, there you go, V and T. Okay, so you can use any letters. Okay, so have a wee look at them. Okay, so you should be able to do every question up to page 10. Okay. And then have a wee look at that website as well. Okay, it might be something on that helps you. Okay. Nice one. Okay. I think that's as much as I want to do tonight. Any questions? Super. Okay. Shouldn't officially be reading my emails over holiday, but I probably will. So if you've got any questions, fire it over to me. Okay, and I'll try and get back as soon as I possibly can. Okay. So I'll probably check it in between Christmas and New Year and some other time as well. Okay. But don't be afraid, just fire me a wee message, fire me an email, and do that. Other than that, guys, yeah, exactly that. Have a good Christmas, okay? Make the most of it, what we can, okay? And I'll see you on the 6th. All right, guys, appreciate that.
Thank you.
Soon.